Focus isn't something we simply choose in the moment. It's a neurochemical dance, a physiological process that either works for us or against us. And if you've ever sat down to work with the best intentions and found yourself reaching for your phone, checking your emails, or spiraling into distractions, it's not a sign of weakness, it's biology. Let's start at the center of this system, the prefrontal cortex. This is the part of your brain right behind your forehead. It's the command center responsible for decision making, planning, attention regulation, and suppressing impulses. In a perfectly functioning system, this region helps you stay locked into your tasks, resist distraction, and move with intention. But here's the catch. Your prefrontal cortex is in a constant battle, and the enemies are both external and internal. Externally, we live in a world that's designed to fracture your attention. Every app, every platform, every piece of content you consume has one underlying goal: hijack your focus and hold it hostage. Your brain, evolutionarily speaking, was never built to multitask across dozens of stimuli in seconds. 10,000 years ago, your attention was tuned to threats, opportunities, and your environment. It was survival-based. Now, that same system is being pulled in 20 directions at once, every waking moment. Internally, your own brain chemistry plays a role in this hijack. Enter dopamine, the molecule of motivation, reward, and drive. Dopamine isn't just about pleasure, it's about anticipation. Every time you get a notification, a new message, like a comment, your brain gets a hit of dopamine. That spike tells your brain, whatever this is, it matters. Over time, your baseline shifts. Your brain starts craving stimulation, not focus. It starts looking for novelty, not depth. That's the real danger. Focus requires that you sit in what neuroscientists call sustained attention. This means you hold your cognitive spotlight on one task, resisting the temptation to shift. But every time you switch tasks, say from a document to a text, or from reading to scrolling, you incur what's called a switching cost. These are not small costs. Research shows that it can take 20 to 30 minutes for your brain to fully refocus after a disruption. And in that window, your mental clarity, memory retention, and task performance drop significantly. Now, let's get more technical. There are specific brain networks that control focus. The dorsal attention network is the one responsible for top-down attention. That's the voluntary, goal-directed kind of focus. When you sit down to read, write, or work, this is the network you want active. On the other hand, the default mode network is what kicks in when your mind wanders, when you're not focused on the outside world, but rather internal thoughts, daydreaming, reflecting, worrying. The problem arises when the default mode network becomes dominant during tasks that require intense concentration. That's when focus collapses. So how do we prevent this shift from happening? It starts with understanding that your ability to focus is governed by neuroplasticity, your brain's ability to change based on experience. Meaning, the more you train your brain to stay focused, the more it becomes your default state. But the reverse is also true. If you train your brain to constantly bounce between stimuli, you degrade your ability to hold attention over time. This isn't philosophical. This is anatomical. Studies using fMRI scans show changes in cortical thickness in the prefrontal regions of individuals who engage in regular focus-based practices like meditation, breath work, and deep work sessions. Let's talk about the locus coeruleus, a small nucleus in the brainstem that plays a huge role in focus. It releases norepinephrine, which increases alertness and arousal. When it fires at just the right levels, you enter a state of optimal cognitive performance. Too much activation, you feel anxious, scattered, over alert. Too little, you feel drowsy, unfocused, disengaged. That's why physical state, sleep, hydration, posture, even light exposure, directly affects your ability to focus. The brain and body are one system. You can't separate cognitive performance from physical health. And finally, let's explore a truth that many avoid. Focus is uncomfortable. It's friction. You're directing energy into one thing at the expense of everything else. The brain doesn't always want to focus. It wants to conserve energy. That's why it's easier to scroll than to study, to talk than to train, to consume than to create. But here's the key. When you understand the biology behind this resistance, you stop personalizing the struggles. You stop blaming yourself for not being disciplined enough and start seeing focus as a biological process that can be influenced, regulated, and improved. The shift happens when you begin to notice the sensations that accompany distraction, the subtle urge to check, to shift, to wander. And rather than following it blindly, you use it as a signal, a cue. That's your moment to lean in, not pull away. Because each time you resist that urge and return your focus to the task at hand, you're strengthening neural pathways. You're rewiring your brain for deep work. You're building a mind that doesn't just react to the world. It directs it. Focus is not something you wake up with. It's something you build. Just like muscle, just like endurance, just like strength. The ability to sit with sustained attention on one task for an extended period of time is a direct result of deliberate training. And if you've ever wondered why you can't seem to lock in, even when the stakes are high, it's not because you're lazy or broken. It's because your brain hasn't been trained to hold focus in the modern environment, but it can be. Your brain operates through circuitry. Electrical impulses, synaptic connections, and neurochemical releases shape every thought and behavior you have. And when it comes to focus, the most important circuits involve the interaction between your prefrontal cortex, your dopaminergic system, and your attentional networks. These circuits adapt to what you repeat. So if you repeatedly split your attention, your brain wires itself to crave novelties. If you train your attention like a sniper, single target zero hesitation, you wire yourself for deep concentration.